In this next section, we want to be able to use formulas for volume of three-dimensional objects to solve real-world problems. Remember that volume means the space contained in the interior of a solid, three-dimensional solid, and we think cubic units when we find volume. Think of words like fill or contain or air, like filling up a balloon with air or filling a container with some sort of liquid. Maybe even examining how much of anything a container will hold. Again, remember cubic units. That could be written like inches cubed or centimeters cubed or some sort of units that are cubed, cubic units. Let's look at a few examples. Remember to use the formula sheet whenever necessary to find the formulas that you need for volume. A rectangular pyramid that is 7 meters tall has a base that measures 5 feet by 3 feet. How many cubic feet are contained inside of this pyramid? So first of all, I see cubic feet. That tells me right away that I'm looking for volume. Rectangular pyramid. So pyramid tells me to look at the formula on my formula sheet for this figure, and volume is what I want. So I'm going to write the formula for the volume, 1/3 capital B times H. Remember that the capital B means the area of the base. And if you look at your formula sheet, that is written down in the bottom portion where the abbreviations are listed. Now, if we don't have a picture, it's helpful to label our picture. So let's go ahead and use the picture that they gave us on the formula sheet and label things that are written there. So for example, they tell us 5 feet by 3 feet is the base. So 5 feet would be the length and 3 feet would be the width, and that the height is 7 meters. So this part right here is 7. So we need to first calculate the area of the base. Now this base is a rectangle. So we want to think of rectangle, and going to our formula, we see that the area of a rectangle is the length times the width. The length is 5, the width is 3. So we're using 5 times 3, or 15, for the area of the base. So 1/3 times 15, and then the height of the pyramid, 7. Then we can compute that. 1/3 of 15 is 5. 5 times 7 is 35. Because we're using feet, I know I need to use feet, and it is cubic units. 35 cubic feet. Number 2, construction workers drill a hole into a concrete cylinder. Determine how many cubic feet of concrete are remaining. So again, cubic feet indicates that I'm going to need to find volume. Because it's a cylinder with a hole that is also a cylinder, I know that I'm going to use the volume formula for the cylinder. So I'm going to start by referencing that from my formula sheet and writing it down on my paper. Now, when there's a hole and I talk about remaining, I want to think of subtracting. When there's a hole and I want to find out what is left. Remaining means what's left. So let's start with the big cylinder. So I'm going to think of having two cylinders here. The big cylinder, or the outer cylinder, finding its volume first. So the outer cylinder, here's the edges of the outer cylinder. I need the radius for the outer cylinder. Well, they show me that it's 10 all the way across, so that means from the middle to the edge, the radius will be 5 feet. And the height of the cylinder goes all the way up and down, the height is 15 feet. And then I can compute that. Now you'll notice that I'm not going to type in and get a decimal, the pi. With the pi, I'm going to leave it without getting a decimal until the very end, because if I round too soon, my answer will be slightly off. So that's the big cylinder. Then I want to think about, I have an inner cylinder. This cylinder right here, we can only see the top of it, but if we could see through, it would look like this. Well, what's the radius of the inner cylinder? Notice that 1 foot is taken off because the inner cylinder ends 1 foot before the outer cylinder. So if it's 5 feet all the way to the outer edge, the inner edge stops 4 feet away. So now we'll think of our small cylinder, or the inner cylinder, which is the whole, and we'll write the formula for that. Pi radius is 4, and then the height. Well, it's just as tall because they drill the hole all the way through, so the height is the same, 15. That makes 240 pi. And then I want to think about finding what's left. Subtract what is remaining. So I'm going to think big, or outer, minus small, and that will be 375 pi minus 240 pi. So I'm going to type in 375 pi minus 240 pi all at once into my calculator so that I'm not rounding before I get to the final answer. 424.1. Now I see I'm using feet, and this is volume, so feet cubed, or cubic feet. Let's see what a problem looks like when we're putting things together instead of taking things out. Number 3, part A. If I could eat every bite of this dessert, how many cubic centimeters, so I see cubic and that makes me think volume, how many cubic centimeters of ice cream and cone, so there's the cone, there's the ice cream, which also fills the cone, could I possibly eat? Consider that the top of this dessert is a hemisphere of ice cream. So we have 2 parts to put together. The top is a hemisphere. That means half of a sphere. The sphere volume is this. So that's what I'm looking for. So I'm going to write that that volume is half of the sphere volume, 4/3 pi r cubed. The bottom portion, the cone, is the cone formula. And that's the entire cone. So the cone volume is 1/3 pi radius squared times height. So let's plug in the values from the picture to get each of these volumes. 1/2 times 4/3 times pi. Radius, well, the radius is half of the diameter. They gave me all the way across, so the radius is 4 centimeters, 4 cubed. Let's go to our calculator to compute that. Again, I don't want a decimal yet because I don't want to have to round until I get to the final answer. Let's do the cone now. The cone, 1/3 pi, the radius is also 4, and the height of the cone shows 12. We get 64 pi, and now I want the entire volume. So the volume, put that all together, 128/3 pi plus, I'm putting them together, 64 pi. Now I can type that all to get approximately 335.1. I see centimeters, centimeters cubed. Now part B asks, how much of the ice cream cone is remaining after I have eaten 1/4 of it? 1/4. That means 1/4 of the ice cream cone. I want to know how much is left after I've eaten 1/4. So remaining, we often think of subtracting. Well, if I have one ice cream cone and I've eaten, think of take away 1/4. 1 minus 1/4 is 3/4. So 3/4 of the ice cream cone is remaining. Well, this is how much of the ice cream cone I started with. I want to see what is 3/4 of the ice cream cone. So 3/4 of means multiply. 3/4 of 335.1 cubic centimeters is approximately 251.3 cubic centimeters.